students, this is Mr. Ivan here. Okay, so this is a logarithm word problem question, which actually, when it comes out in exam, and most of the time it does, I've seen this question in a lot of prelims, O-level papers, okay, and mid-years and whatnot. Okay, it is actually quite a straightforward question where you are supposed to get the marks for this, but there are a few parts which I find that students struggle to answer, and these are specifically part 3, part 4 and part 5. So pay special attention when you reach part 3, part 4 and part 5. Okay, so this question is about a cup of tea left on the table to cool. The temperature formula is given by 24 plus 72, 0.9 to the power of t. So temperature is a function of time. Now part 1 and part 2, part 1 is easy when it is first left. Okay, first left means, so usually for this kind of question at the start, regardless of what kind of formula they give, okay, always find out what is the value when t is equals to 0. Okay, so for part 1, I will have big T is equals to 24 plus 72, 0.9 to the power of 0. Okay, so so this would be equals to 24 plus 72, and you realize that the way I present, okay, I will only write the units at the end. Okay, so at the start it is 98 degrees Celsius. Part 2, find the time taken for the T to be lower than. This is a question that most students struggle. Alright, so when the temperature is lower than 28 degrees. Now, if you want to be good in math presentation, okay, always make sure that you are doing it step by step. Alright, what do I mean by that? So for part 2, temperature lower than means it must be less than 28 degrees Celsius. Alright, and what is T? T is equals to 24 plus 72, 0.9 to the power of t, and this must be less than 28. Okay, so now I'm trying to make t the subject. Okay, so I bring over 72, 0.9 to the power of t must be less than 4, and then so the next step would be 0.9 to the power of t must be less than 1 over 18. Okay, bring 72 over, I'll have 1 over 18. Okay, or rather let's do this in case some of you not sure of what is the mathematics involved. Yeah, this is also fine. Okay, so next part is now when t is a power. Okay, see, when t is a power, you must learn to log both sides. Okay, so when I log both sides, what happens? I will have this Lg 0.9 power t is lesser than Lg 4 over 72. You can use ln as well, it will give you the same kind of functions over there. So the t bring down, alright, t log 0.9 is smaller than Lg 4 over 72. Okay, now the next step is very crucial. Always remember, the next step is always crucial. Okay? Okay, put the 3 star there. Why? Because now over here on the left side, t log 0.9 is lesser than log 4 over 72. But when you bring log 0.9 over, okay, so I write down here first, 4 over 72 divide by log 0.9. You have to change the sign from lesser than to more than. Okay, change sign. Okay, change sign because why? Because when you have log 0.9 is a negative number. Okay, log 0.9 is a negative number. So when you divide by a negative number, the basics of inequality says that when you divide by a negative number, you must change the sign. Okay, so log a fraction, any fraction lesser than 1, log a fraction that is lesser than 1 will always give you a negative answer. Okay, so when you divide by a negative answer, you must change the sign. Okay, so in this case the answer is t must be greater than 27.4 minutes. Okay, so this is also an important part of logarithm word problem that many students fail to understand how to present and how to do it correctly. Okay, so when you divide by a log of a fraction that is lesser than 1, remember that it will give you a negative number. Okay, so next part. Alright, part 3, sketch the graph of T versus temperature versus time. This is also another part whereby a lot of students leave it blank. Okay, so how does it go? First, before you sketch the graph of T is equals to 24 plus 72 then times 0.9 to the power of T, right? You must know the mother curve. So on the right, I'm going to draw the mother curve. What does the mother curve mean? So you must know roughly the beginning, how does the beginning shape of the graph looks like? And it involves a series of transformation. First, in your you should do a sketch of this, okay? Because this is the mother curve of y equals to a to the power of x. But in this case, right, this a is greater than 1. Okay? So if I'm going to draw this 0.9 to the power of t, right? Okay, I have to do this. Okay, so first I need to think of y equals to 0.9 to the power of t. 0.9 to the power of t, right, is 9 is lesser than 1. Okay, so if it's lesser than 1, it's not going to be this way, it is going to be in, okay, this manner. Okay, so this is y equals to a to the power of x, right, for a smaller than 1. Okay, so how do I remember? This is called the aeroplane landing. Okay, aeroplane landing. Alright, so you must know your chapter 5 very well, graphical representations, to know what are the mother curve. This is called aeroplane taking off. Okay, I will also do a video about it too, so that you can understand what curve is for what. Alright, so for in this case, this is 0.9 to the power of t, so it's going down. Alright, and then you must also understand that there is an asymptote here, asymptote here, asymptote here. Alright, so in this question, this is your mother curve for him. Now, what happens if you add 24? So when you add 24, right, the whole graph will translate up, move up 24 units. Okay, so how does your graph look like? Your graph will look like this. Okay, so and again, because this is application question, time can only start from 0, so you cannot have this part. Alright, so I will have the beginning temperature, which it starts to cool, is 98 degrees Celsius. Okay, and it starts to cool and it goes down. Down to where? So you are supposed to label this, is called an asymptote. Is the part where the t will go very close to, but it will never reach, and it will be 24. Okay, so this is how you plot your graph. First, you must know your mother curve, how is the shape of the graph going to be like, and by moving up 24 units, your asymptote also move up 24 units, so hence, that's why your graph is in this manner with an asymptote at 24 and a starting point of 98 degrees Celsius. Okay, so this is for part 3. Okay, part 4, express t in logarithmic form. It means that making small t the subject. So I'll write down big T is equals to 72 plus 24 plus 24 plus 72 bracket 0.9 to the power of t. So I want to make small t the subject. Okay, I bring this over. T is minus 24 is equals to 72 bracket 0.9 to the power of small t, and then t minus 24 over 72 is equals to 0.9 to the power of t. Now, question from here. It seems like it's logical to do log both sides or log both sides. Just that the difference is we are trying to make t the subject. Okay, so t is now a power. What should we log on both sides such that 0.9 disappear? Okay, so we should log base 0.9. 24 over 72 is equals to log base 0.9 0.9 to the power of t. Why? In this way my t can come down to here. Okay, so it's equals to small t, and 0 log base 0.9 0.9 is equals to 1. So that's why t is equals to log 0.9 bracket t minus 24 over 72, and then we write back, so t equals to log 0.9 over 72. Alright, and for part 5, it's a very common question which students also leave it blank. What happens to the temperature of the cup of tea in the long run? Now, in the long run, this is one way of putting it. Sometimes question may ask, as t becomes large. Okay, yep, or in the long run, and explain its significance. Alright, significance. Now, the way to present this is very important, and this shows the examiner whether the students truly understand, you know, log as a whole topic or not. Alright, so this will be equals to 24 plus 72, 0.9 to the power of t. How do we present is as t becomes large, okay, becomes large, or if you want to do it more professionally, you say t approaches to infinity. Okay, this is a mathematical way of writing. And now we can key into our calculator and key in a very big number as your t into the calculator. For example, 999999999. Okay, we'll find that t to the power 0.9 to the power of 9999999 will approach to 0. Okay, will approach to 0. This 0 looks like a potato. Okay, will approach to 0. Okay, so what does this mean? So this means that t will be equals to 24, because 0.9 to the power of t is equals to 0 means it will, the 72 to the times 0.9 to the power of t will become very insignificant, okay, as small t approach to infinity. Okay, so this is what they want. It will be equal to 24 degrees Celsius. Okay, and what is the significance of it? Alright, so we go back to the graph to understand it a little bit more. Okay, so you look at the graph which is over here. At the start, when your T is piping hot, it's 98 degrees. So you leave it to cool, it will keep on decreasing until it reaches 24 degrees. So the question is asking, what is the significance of 24 degrees? Okay, so when you leave the T to cool, it will not, the temperature will decrease, yes, but it will not decrease up till it becomes 0 or -5 or -100. Alright, it will become, the T will cool to room temperature. Okay, no matter how long you put your tea outside, okay, the temperature that you can only reach to is room temperature, and that is what the whole question wants. So at the start, it's about substitution, seeing whether you can put in a value of t to the power 0 to find what is the temperature. Okay, there is this inequality part. That important thing is when you divide by a log of a fraction, you have to flip the sign of the inequality. Okay, third part talks about the graph. Knowing how does the mother graph looks like is very important. Moving the asymptote up is very important. And then next, as t goes to infinity or t becomes very large, the behavior of the whole formula, what would it be like? Okay, and these are the things that you have to know, and good luck.